chain multiplication. We in the last class we just started and we introduced the concept of matrix chain multiplication, and today now we shall continue with that, and today we shall understand that matrix chain multiplication with an example. Okay, understanding the example, we can then go for the development of the algorithm. Okay, so please try to concentrate with 100%. So I'm sharing my screen. Hope you can see my screen. Okay, so just have a in the time we do a brief review of the yesterday's class, last class, about the matrix chain multiplication. So what is the problem? It was that is, we are given a sequence of n matrices, and a1 a2 dot 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 an, so as to compute the matrix product a1 dot a2 dot an. Then there are we are not actually interested on the final matrix product, rather we are interested on how this product is being calculated. How should we, for example, if I am given, yes, so yeah, if we are given with four matrices, then how should we compute the product, in this way or this way or this way? So this matrix chain multiplication problem is a problem of finding an answer to the question how should we calculate the product of n given matrices, not the actual value of the product. So and we have seen that it's nothing but a parenthesization problem. Okay, parenthesization problem, and uh, we know that parenthesization matters because that gives us, you know, um, I mean, same product, but the performances in different parenthesizations are different. So we want to have that parenthesization which will give, uh, which will be involved in minimum number of operations, multiplication operations. Okay. Then we understand that problem mathematically, that if we are given a chain of n matrices, let let that sequence of matrices are is a1 comma a2 dot dot an with matrix dimension, okay, with matrix dimension, excuse me. Okay, sorry. So it's a matrix dimension, with any matrix dimension ai, dimension of ai matrix is pi minus 1 cross pi. Okay, so if we do that, um, so then what we have, the product is parenthesized in such a way that minimizes the number of scalar multiplications. Next we understood this frame, that Pn is the number of alternative parenthesizations, suggestions of a given sequence P, then Pn will be following a recurrence relation Pk into Pn minus k for k equal to 1 to n minus a 1. Then if I apply a simple brute force, it is exponential of n, so very poor algorithm. So now that's why we can go for solving this problem by dynamic programming. So we are modeling the problem as a dynamic programming problem. So let Aij, Ai2j denotes the matrix product Ai dot Ai plus 1 dot Aj. Now if I less than j, then this product can be divided into two subproducts. One is Ai to k, another is a k plus 1 to j. By dividing the parenthization, splitting the parenthization between the matrices ak and ak plus 1, where k may be k will be equal to 1 to j, excluding j. Okay. Now optimal parenthization. So we are doing a parenthization. Here we are doing a parenthesization. So we are doing a parenthesization, but where we are doing the parenthesization at k, splitting the product between ak and ak plus 1. So one subsequence will be a1 at ai plus 1 dot ak, another subsequence will be ak plus 1 ak plus 2 dot aj. So but the question is, what is the value of k? That is unknown. So we may have several possibilities of k. K may be equal to 1, k may be equal to I plus 1, okay, k may be equal to I plus 2 dot dot dot, k equal to j minus 1. So all are these possible values for k, and for all those values of k we may have a possible parenthesization, and out of those parenthesizations we have to select that parenthesization which will be involved with minimum number of scalar multiplications. Okay, and then uh, we modeled optimal parenthesization means it's nothing but parenthesization problem means it's nothing but a problem of finding suboptimal parenthesizations, and optimal parenthesization means finding minimum cost. Then we have modeled the cost. So parenthesization of a pointing j, ai pointing j is equivalent to cost of ai pointing j. That is equal to cost of ai to k plus cost of a k plus 1 to j plus pi minus 1 pk pj. So up to this we have done. Today we shall continue. Okay. Okay. I hope okay, only 5 people. Okay. This is very important. So now okay, let me announce that is quiz I have shared on Moodle. It's available from yesterday, and deadline is on Monday, and the quiz is based on matrix chain multiplication. 4 questions were there. So there are only, what are the values of k? You know, we know that I less than equal to k less than j. That means there are only j minus I values of k possible, okay, which are k equal to y plus 1, I plus 2 dot dot dot, okay, excluding j. So last value of k is j minus 1. These are very important to because we want to formulate, develop the algorithm, So hence, so for what was the model we had, that is cost Aij is computed as sum of cost Ai to k, this one plus Pi minus. So what is the value of k? Here I to j. That means we will not have a single value for Aij. Rather we will have more than one values possible for Ai to j. Right? That is, we shall have not only one but more than one values for cost of you have written quiz 4 sir in matrix. Yes, it is quiz 4. Quiz 3 is pending yet. A I pointing J. Okay. So more than one values for this. How many values? This J minus 1 number of values. Yes. Okay. So this how many values we have for cost of I to j? J minus 1 number of values. Okay, and out of those, in j minus, and among this j minus I number of values, we have to select the minimum. Okay, that means immediately my model becomes m ij. Okay, m ij. Okay, m I equal to, ij equal to 0 and equal to mean of m I comma k plus m k plus 1 comma j plus p I minus 1 into p k into p j. Right. Okay. So this is true when I is no less than j. I hope you got it. Okay, so we are taking j minus I number of values of mij and selecting the minimum among this, and where here k is varying, from 1 to 1 less than equal to k less than j. Okay, fine. So this is the mathematical of any mij. Okay, and what we want to do here, from here, we want to, okay, I just have to define here what is mij. And so mi comma j is mij is the, the cost of a I to j. Okay, that we are denoting as mi to j. This is the matrix product ai plus 1 dot up to aj, and the cost of computing that matrix product is mij. Okay, and similarly we have sij. Let si comma j is the value that provides mi comma j. Okay, so this is the meaning. So please raise me question. Okay, if you have any doubt, any question, you can ping me right now. Okay, anytime, no issue. Okay, so after that we want to have a bookkeeping like this. We are going very slow because to understand the algorithm, you know, we have to be very concentrated. Let's say we have some this kind of thing, a table. Similarly we have here a table. Okay, so this is right. Okay, so what we want to do now here, let's say this is 1, this is 2 dot. Let this be the nth matrix. Again this is 1, this is 2 dot. This is nth matrix. Similarly here provide 1 2 dot. This is n. Similarly here 1 2 dot. Okay, so this is for mij or M matrix, and this is your S. Okay, here we will fill up all the values of mij. Here we will fill up all the values of Sij. Okay, and you know this mii are all zeros. The diagonal elements are zeros, where I becomes equal to j. Okay, and also we have good I mean case, that is these cells are not to be filled up. Okay, so this lower triangle are not to be filled up, because in this region, similarly here, this lower triangle we do not have to fill up. Okay, so that gives us an efficiency to compute this method. Okay, to compute for this method. So this green shaded, I mean this lower triangular portion is not to be filled up, because in all these cells positions, you know, I is not less than j, but I want to have I less than j. Okay, fine. Now let's go for an example. Consider the 4 matrix product. Okay, A, one, let's say 5 cross 4. Okay. Then dot a suffix 2. This is a second matrix, A2 matrix. We will use standard notation, that is 4 cross 6. Then A suffix 3. Then suffix it is 6 cross 2. And that is 2 cross 7. So this is a matrix product we are given to compute. Okay, and what we have to do here, we have to find the optimal parenthesization of the product. Okay, so let's go for the solution. Okay, so first we start with m I comma j equal to 0, I comma I equal to 0. So we try to draw a table. So I recommend all of you, 9 are there, so please take a paper pen. I hope you are taking with that. So I take a paper pen and also the calculator, and this is we are given 4 matrices, so it's a 4 cross 4 table. For M, we want to keep a bookkeeping record for M and S, and after filling this table we can find out the optimal parenthesization. At any moment, if you have any doubt, please ask. It will be not a difficult thing to understand. Everything is easy to understand. Okay, so this is your M. Here we have matrix 1, this is for matrix 2, this is for matrix 3, this is for matrix 4. Similarly, 1, 2, 3, 4, 1. Okay. So this is our case. Now for I less than j, we have you know, for I less than j, we have m I comma j is equal to, okay, so m comma k plus m k plus 1 comma j, then plus, try to remember the formula, pi minus 1, please note it down, pi minus 1, then p k, then p then J. Okay. Let's take length of sequence be equal to 2. Let the length of any sequence is L, denoted by L, and let's start with L equal to 2. Before that, I just wanted to mention that we are given a sequence P, okay, which is P is an array actually. Okay, you can think P is a list or array sequence. So this is given as 5, 4, 6, 6, then 2, then 7. Okay, of which length is 5. Okay, given 4 matrices. This is very important thing. So if we are given 4 matrices, we should have a sequence of 5 length. If we are given n matrices, we shall have, so for n matrices of P will be equal to n plus 1. Okay, fine. So just to take this, five, comma 4, comma 6, comma 7. Okay. This 5, 4, then this 6, 4, 6, then this 6, 2, and then this 2, 7. Okay. This is nothing but, you know, a, this is nothing but a suffix 1 dot x. Okay, similarly this is nothing but a suffix 2, right? Similarly, this is observations are very important, very close observation, because we are working with a lot of notations. This is 4, and finally this means a 4 5. Okay, so this, if I take I'm now at this moment, see what is the case. If I take 5, 4, that means we are considering a1 dot a2. If I take 4, 6, okay, the sequence 4, 6, that means it is corresponding to a2 dot a3. Similarly, if I take 6, 2, it corresponds to a3, 4, 4, 2, 7 corresponding to a4, 5, a5. So this is the meaning, the length of 2. The sequence of the length of sequence L equal to 2 means either a1, a2, or a2, a3, or a3, a4, or a4, a5, something like that. Okay, a1, a2, right. ठीक है. So let's take a length of 2. Then what we have, okay, or in other case, okay, you can also interpret like this, okay, like that. This is 5 4 means is the dimension of the first matrix A1. Similarly, uh, you can consider A2 is the dimension of the next sequence 4 6, which is A2. Similarly, this is A3, means 6 2, and then A4 is dimension 2 cross 7. That means this 2 7. If you consider 2 7, that means it's corresponding to this. Okay, you can also think like this, no issue. So here, if I take length of 2, that means we have m of 1 comma 2 equal to, okay.
Hello,
Next,
welcome to Skype call testing service. After the beep, please record a message. Afterwards,
m 2 comma 3, okay. Next we have m 3 comma 4. So these are the only possibilities. 3 possibilities we have of length equal to 2. Means if m12 means is the cost of the product a1 into a2. This is the cost of the product a2 into a3. This is the cost of the product a3 into a4. No other pair of matrix product is possible, right? We are given 4 matrices. Okay, so this is equal to, and this corresponds to, I just want to here write that here what is the value of k? Can you tell me? Okay, you uh, one by one, those who have answer, just interact. What is the value you have at this moment of k? K is, I less than equal to k, I less than equal to k less than j. So for this mi2 means here we have I equal to 1, I equal to 1 and j equal to 2. So then what will be the value of k? How many value we have k? So if k has to be greater than equal to 1 but less than 2, that means only value of k possible at this moment is 1. So this corresponding to this. Similarly, this corresponds to, right. Similarly, here I equals to 2, j equals to 3, so that k will be equal to 2. Similarly, here we have I equal to 3, j equal to 4, and k equals to 3. Okay? So now at this moment, let us try to find the cost. What is mi2? So mi2, as per the formula, just put it over here. Okay. As per the formula, you put it mik means 1 comma 1, k is equal to 1. Okay. Then plus m 2 comma 2, k plus 1 equal to 2, j is equal to 2. And next we have what? That is p. Okay, what is the value of I minus 1? 0, because I is 0. Okay, So let me write over here what are P0, P1. So this is, P0, comma P1, comma P2, comma P3, comma P4. This is equivalent to this one. That means P0 equal to 5, P1 equal to 4, P2 equal to 6, P3 equal to 2, P4 equal to 7. So this is that P0. So P0, then dot P suffix, K is here 1. Next dot P suffix J, which is 2. So now we are in a position to calculate this thing. Calculate over here. That is equals to M11, that is 0, plus M22, that is also 0. And what is P0? P0 equal to 5. So 5 into P1. P1 means it is given as a 4, and then P2 equal to 6. Okay, so 4 into 6. So in the next line we have answer 120. Okay, similarly you try to find out this one. You try to find out M23, and similarly you find out M34, and tell me what are the answers. Just expand this according to the formula. This is M2,
Sir,
comma
why M11 is 0?
See, MII equal to 0. Are you asking
Oh.
me why MII equal to 0?
No. Understand, sir. Understand.
Anyone want to share me the answer? Why we have, what is the logic behind this MII equal to 0? Anyone want to answer why MII equal to 0? Shobik? Rahul? MII equal to 0. Why?
Sir, row column equal.
Row index, column index are equal. So in that case, why MII equal to 0? What is the meaning of that thing? Our condition is 0. That is the condition 0. That is the condition 0. But we have established that condition that MII must be equal to 0. But why MII must be equal to 0? What is the logic? One line answer. This is the reason.
Because
That's
there
why.
because there is no K value between I and I.
That's fine. But any other answer? Any other answer? Okay, so MII means what is the parenthesization? MII means the parenthesization means like that. MII is corresponding to, corresponding to a parenthesization of a matrix AI. Okay, it's I to I product. AI matrix is being multiplied with AI matrix, right? That means it is containing actually a single matrix. So I to I means it's containing a single matrix, and for a single matrix you do not have to compute any multiplication. So number of scalar multiplications equal to 0. No need of any multiplication over there. And what is MII? It is the cost of the product AI. So what is the cost of multiplication of a single matrix? 0. No scalar multiplications. That's why it is 0. Okay. So have you calculated this value? M22 then plus M3, 3 plus P, P will be 2, sorry, not 2, P1, then dot P suffix 2, then dot P3, P2 dot P3. So are you getting why this, all of you are getting, I hope? Okay. So in the next line, equal to again 0 plus 0 plus, what are P1, P2, P3? 462. 4 multiplied by 6 multiplied by 2. So the answer is 48. Okay. Acha, we forgot to store the bookkeepings. So MII equal to 0. That means immediately you fill up the table like this. This is 0. This is 0. This is 0. And also this is 0. Okay. And as you got only a single value for M12, no other possible value is available for M12. So M12 is going to be this 120. So fill up, this is the M120, M12. So fill up that position by 120. So this is the cost of multiplying a product A1 dot A2. Next you fill up M23 by 48. So M23 means this one, 48. Okay. Similarly, you calculate here 3,3 plus M 4,4 plus P suffix 2 dot P suffix 3 dot P suffix 4, P4. So which is equal to 0 plus 0 plus how much? P2, P3, P4, P2, P3, 6, 2, 7. Okay. So here we have 2, right, 7, right. So equal to 84. Immediately you try to fill up here 84. Only one person doing the calculation, others are what, sleeping? Okay, so very good problem this is, so try to involve yourself. So all these values we got, and these elaborate discussions are not available in any book. Okay, next what you do, you try to validate these results which have been calculated based on the formula. We human being can calculate this M12, M23, M34 without this formula. Okay, how? See here M1, 2, which is the cost of multiplying cost of A1 A1 dot A2. And what is A1 dimension? 5 cross 4, right? A1 5 cross 4 from this table. A2 is 4 cross 6. That means 5 cross 4 and then 4 cross 6. So this is the total number of scalar multiplications. So 120. So without the formula we can compute M12. Similarly, we can also verify this result M1 2, 3, okay, equal to cost of this is A product A2 multiplied by A1 A3, and that is equal to as per the picture. Can you see that picture? Okay, let me right. So as per the picture, this A2 is 4 cross 6, A3 is 6 cross 2, so 4 6 2. Okay, so 4 multiplied by 6 multiplied by 2. Okay, and that is equal to 48. Similarly, 6 to 7. Okay, 6 to 7 here, M 3 comma 4, which is the cost of A 3 okay, and that is equal to 6 multiplied by 2 multiplied by 7, and that is equal to 82. Without formula, we can also calculate those costs and verify. Now obviously this formula has been made for not this simple values, for large number of matrix chain where n is very large, 100, 50. Okay, so in that case it will be very difficult to do hand calculation. Okay, so this is the iteration number 1, when we have taken length of 2. Next we will go for length equal to 3. Length equal to 3. Length L equal to 3. So what we are getting? So first is we will get here M 1 comma 3. Okay, and we will get M 2 comma 4. So these are the only two possible sequences or cost of sequences. Okay, because we have M13 means this position, M24 means this position. So these are the only two positions, okay, available at this moment. So what is M13 representing? M13 represents, this is how we have written, right? It's corresponding to I equal to 1, J equal to 3. So what should be the value of K? Can you tell me, anyone? So please tell me what are the possible values for K? 2 and 1, right? That is correct. So Sandeep got the answer that K will be equal to 1 and 2. Both are possible values. So for both these values, K equal to 1 and K equal to 2, we have to compute the value of M1 and 3. Okay, that means here we are getting two possible values from values of M13. Okay, so let's take that. Because we have okay, here I am writing I less than equal to K less than J. That means what is the value of I? That is 1. What is the value of J? And that is 3. That means we will have K equal to 1. isn't it? So this corresponds to, let's say, 1. This is corresponding to k equal to 2. So for k equal to 1 we will have one value, for k equal to 2 we will have the other value. Okay, so here we will get, according to the formula, that is m 1 comma 3 is equal to m 1 comma 2, k equal to, sorry, k equal to 1, sorry, m comma 1 1 comma 1 plus m 2 comma 3 plus p 0 dot p 1 dot p suffix 3. Okay, so in the next line you can write that equal to m11 equal to 0 plus m23, which already have been calculated. Here you can see m23, this is 48. Okay, so here you put that value. So a value which already is present in the table, that is being used here. That's why we were taking the bookkeeping record, that is the table, you know. Okay, so 48 plus p0. P0 is, I think, 5, the 5 4 6 2 7, that is the sequence. So 5 into p1 is 4, then it was 6, then 2, so it is 2. So in the next line, what is the answer? So 5 4s are 20, 24, 88. Okay, you got it? Fine. Okay. So next what we got? Next we got that f m 1 comma 2, no, 1 comma 3, the value is 1 comma 3, and it is equal to m 1 comma, at k is here 2, so plus then m 3 comma 3, then plus p, p 0 dot p suffix k is 2, then pj is p3. So in the next line, equal to 1 2 we can take from our bookkeeping record. 1 2 is 120, 1 2 is 120 plus 0 plus p0 equal to 5, p2 equal to 6, and p3 equal to 2. Okay, and that gives us right, 180. So this is the value of, these are the two values of M13. And then what is our model, mathematical model of Mij? Mij model is Mij equal to mean of all the possible values of Mij. We got here two possible values of M1 comma 3, out of which you have to take the minimum. So here we got 88 and 180. So that means next job is M1 comma 3 will be equal to mean of 88 comma 180. That is 88. And correspondingly, what is the value of k you got? It's giving us the minimum value of Mi3. So this k equal to 1 gives us the minimum value of M13, which is 88. That means k equal to 1, which is going to be my S1 comma 3. Okay, so this is the case. right? Okay, so immediately you try to fill up the table, update the table. Here we got 88 M13, okay, and immediately the corresponding value of S13 becomes 1. We forgot to fill up this. S120 comes from the value k equal to 1 here. 148 comes from k equal to 2, and 84 comes from k equal to 3. So these values, the corresponding locations are nothing but this is 1, this is 2, this is 3. Okay, so we are left with 2 locations, then we can complete the example. Very small example, but it's taking some time to teach, but once you understand it properly, you can quickly solve this kind of problem. Okay, so next go for the next case. Let's extend the thing. Now we are going for M. What is M1324? So M2, please you do yourself, okay, and tell me the answer. I equal to 2. I just want to check. তোমরা করে নাও কেমন পাচ্ছ কিনা দেখো, চেষ্টা করো। J equal to 4, K equal to কত হবে? সবাই তো এখানে বাংলা বোঝে। K equal to 2 and 3, good. So K equal to 2 and 3, তো আবার সেই একই রকম করছি। Okay. So M24 লেখো তোমরা, এক্সপান্ড করে লেখো প্রপারলি যেভাবে আমি লিখছি। M2,4 is equal to M2, here K equals to so this is 3, this is 2, so M2, suffix three four was 84. 34 was 84. P1 multiplied by 6 multiplied by P4. Right, and then similarly here we got is equal to M K3 2 3 was that 2 3 was 48, so this is 48 plus P1 was 4 4 cross P1 P3 equal to 104. Okay, so after 30, 104, 3, 104, 104, and it is 3. Next we go for we have I hope you are following. So this is not done. It is what we have. Suffix 2, 4. So similarly, this is suffix is 20 plus 3, 4 is 6, 4 is 30, 30 10, 330. So this is zero. Enter 1 3 is cross 3 which cross is equal to 70 So we have taken this to value. Now we have to proceed, extend this, and finally what we got. That is immediately 158. So here we got 150, and that is 3. So you got the result so far. So this is our, this is the M table, this is the S table, okay, and we got all the suboptimal results. Now we want to combine the suboptimal results to form the parent optimal solution, which is the dynamic programming. Okay, so what we wanted to do, that is our solution is the optimal parenthesization. Optimal parenthesization is first you write here a suffix 1, then give a suffix 3, 4. So how should we parenthesize? So okay, so let's see. So this is nothing but a suffix 1 to 4, right? This is equal to a1 to 4. So if I have a1 to 4, I have to split this product a1 to 4 for a value k equal to what? 1 to 4. 1 to 4 means, can anyone tell me from this figure, 1 to 4, what I have to? This is the 1 to 4. You are not getting. This is the 1 to 4. A is 1 to 4. So I must get the answer at this moment. What will be the value of k? where should I split? Ultimately the bracket is there, right? This is the bracket, overall bracket, but I want to split this sequence into two subsequences. Where should I split? What should be that value of k? There I want to split. So that k value is given by s. So this is the sik, which is 3. That means at 3 position I have to do a splitting. Okay, forget about this bracket for the time being. So this is the next. We have 1 to 3, right? So this is nothing but 1 to 3. This is right. So 1 to 3 means it is 1. S1 3 is 1. That means we have to split this, which okay. Right. So at this moment we have the product A1 to 4. So A1 to 4, this product have to be splitted for some value of k. What is the value of k? That is given by this S matrix, S table. So to split A1 to 4, you have to collect the value of k from S1 to 4. This is S1 to 4, which is 3. So k should be the value of k should be equal to 3, where I should do the splitting. Okay, so this is one subsequence corresponding to k equal to 3, and this is the second subsequence, A4. Next we have A1 dot A2 dot A3. We can't multiply this. We have to take a pair of matrices. Which pair? A1 A2 or A2 A3? That means we are trying to apply here a suitable parenthesis, right? What is the parenthesization? That means what is the value of k here? That will be given by S1 to 3. What is S1 to 3? As it is a product A1 to 3, for A1 to 3 we have to collect the value S1 to 3. This is the value S1 to 3. Okay, S1 to 3. That means now what I have to do, I have to split at 1. That means one subsequence will be A2 to A3 and the other subsequence will be A1. Right? So this is done. Now complete the entire parenthesis. Right. So first A2, A3 will be performed. Then that product A2, A3 will be multiplied with A1. Then A1, A2, A3 will be multiplied with A4. Okay. And at this moment, the minimum number of scalar multiplications. So first you do A2 into A3. So A2 dimension was 4 cross 6. Then A3 dimension was 6 cross 2. So multiplied by 2. So this is the number of scalar multiplications for product A2 A3. Then okay, let me write in this manner, you will understand better. Okay, so let me write in this manner. So A, okay, so A inside which A1 suffix, this is my notation, so for your convenience I prepared this. So A1 5 cross 4, okay, then a dot product with here. Okay, so what is the number of scalar multiplications in this A2 A3? We just got to know that that is 5 cross, no, that's not 5, that is A2 A3, 4 cross 6 cross 2. Okay, just check the dimensions, you can find the answer. So this is 4 cross 6 cross 2. Okay, and after this multiplication A2 A3, I am getting the dimension, new dimension of the product A2 A3. What is that dimension? That you specify over here. The new dimension is 4 cross 6 cross 2, that means 4 cross 2. Right? And then dot, you give this bracket first here. This will be computed here. Take computed here again first, then suffix 4. Which is having dimension, you know, A4 dimension is 2 cross 7. 2 cross 7. Okay. So now in the next line you proceed equal to, so A1 is getting multiplied with this product. So 4 plus 6, 4 6 24, 48, 48. So 5 cross 4 is getting multiplied with 4 cross 2. So in this multiplication we have 4 into 2, 5 into 4 into 2, right? And this matrix dimension, new product dimension is 5 cross 4 cross 2, so 5 cross 2, so 5 cross 2, right? And already we had this result 4 6 into 2, right? So that is 48. That is 48. Okay. And this is 48, and this is getting multiplied with this one. A4, then here we apply 2 cross 7. Okay, so 5 cross 2, 2 cross 7, fine. And already we got answer 48, which is coming from A2 dot A3. So in the next line, you got 5 4 2, that is 40. 5 4 20, 40 plus the product, scalar multiplications in the product, 5 cross 2, 2 cross 7, that is 5 cross 2 cross 7 plus 48, right? So enter, that is 70. So equal to 40 plus 70 plus 48, and the answer is equal to 158. Okay, so this is the answer. So I hope you understood well the entire example illustration. Okay, already it's 2 p.m. Okay, so any query up to this? We have to close here because I have a class first year.
হ্যাঁ বলছি এম 4
কোথায় বলছো?
মানে ওই যে পার্টগুলো প্লাস 1 মানে কস্টটা M2 বা M31 এগুলো কে উপর ডিপেন্ড করছে বলে
সবথেকে বেস্ট এই যে, সো এই যে লোয়ার ট্রায়াঙ্গুলার যে পোরশনটায় এখানে আমরা ক্যালকুলেট করছি না, এই কারণে এখানে i লেস দেন j হচ্ছে না, এখানে i গ্রেটার দেন j, i লেস দেন j শুধু আপার ট্রায়াঙ্গুলার ভার্সনটাতে আছে, পোরশনটাতে আছে। আমাদের তো i লেস দেন j নিয়ে কাজ, এই যে i লেস দেন j, ঠিক আছে?
ঠিক আছে স্যার,
হ্যাঁ এটাই হচ্ছে বেস্ট রিজন, বেস্ট আনসার, এক্সপ্লেনেশন কি। আর কিছু বইতে দেখবে একটু ঘুরিয়ে ওই ম্যাট্রিক্সটাকে ঘুরিয়ে এরকম করেছে, যেটা তোমাদের সুবিধা হয় বুঝতে পারলেই হলো, প্রবলেমটা সলভ করাটা নিয়ে কথা। তো আমি এলাবোরেটলি একটু ডিসকাস করে দিলাম, বইতে এত ভেঙে ভেঙে কোথাও করা নেই, তো এটা আর কি করে দিলাম আর কি, ঠিক আছে। বিকজ এরপরে আমরা অ্যালগোরিদম ডেভেলপ করবো, এখন তো আর হলো না। অ্যালগোরিদম ডেভেলপ করতে গিয়ে ইয়েস আই উইল শেয়ার ইট। সো অ্যালগোরিদম ডেভেলপ কীভাবে করা যায়, এতটা যদি আমরা ডেপথে বুঝে গেছি, তো সবাইকে বুঝতে পেরেছো এখানে যারা যারা আছো মোটামুটি কমপ্লিটলি?
হ্যাঁ স্যার, মোটামুটি বুঝেছি।
Good. So if you understood this topic, you can't believe matrix chain multiplication is one of the toughest topic of this subject. One of the toughest one. Matrix chain multiplication. মানে, okay, solving an example or a problem it's not that much a big deal. But earlierly, when we started about that problem, how to find an optimal parenthesizations. So that's a very, very typical question, very tricky question, and someone has modeled this algorithm. Okay, so hats off to that person. Okay, the answer of the last two quizzes. Yet I will find some time to provide the solution. Okay, so next class we will go for the algorithm development and another very advanced topic, which is in graph theory, that is transitive closure. Okay, transitive closure and topological sorting. Those will be our next topic of discussion. Okay, so along before that we will wrap up the development of the algorithm. So we can close the call if we do not have any question and start solving the quiz questions. I have given you two problems regarding matrix chain problem. So there were 6 matrices. So do this procedure for 6 matrices. Any other question, or you can close the call? You can close the call. Okay.